So here's how you can determine your concentration of IgG um, from the very initial serum, the, the bovine serum that we had. All right. So basically, right, I'm going to go forward to explain this, and then we're going to go backwards, what you guys need to do. Okay. So initially, we had 2 mils of this bovine serum over here, right? And the concentration is a certain concentration. The lab technician took 2 milliliters of this initial concentration and put it in this falcon tube over here, right? That green tube. Remember, it was on your lab bench and you guys were mixing it up, right? I told you to keep mixing them up. So this contained 2 milliliters of IgG, right? And ion exchange medium. Of course, going from this 2 mils to this 12 milliliters will dilute your serum, right? Then we took this and we centrifuged it, right? And then what we did was we took this 12 mils, right? And we aspirated up with a pipette, either 0.25 mils to put into tube 8 or 0.5 mils to put into tube 9, right? And these are the tubes that we have here. So we took a small concentration of this solution here, right? And we put it into our tube 8 or 9. In tube 8 or 9, we had biruet reagent, right? We had the IgG, and we had double distilled, and depending on whether we were in tube 8 or 9, there was different IgG or double distilled volumes, but the total volume of this test tube was always, I believe, 6 mils, right? Here I wrote 6 mils. So then you took this and you checked the absorbance of it, right? You took a small amount of this and you looked at the absorbance and got a final concentration. Let's work backwards now, right? So we know that your tube, right, had 6 mils of biruet reagent, water, supernatant. Altogether, this was 6 mils. And the concentration of this specific tube, right, found with the absorbance and looking at your standard curve, right? From your standard curve, you can tell what this tube over here would have as a concentration, right? Remember, you made your standard curve using BSA as well as biruet reagent and double distilled water. So you're controlling for the same things and you're creating a curve with these reagents. So from your curve, you can tell how much this test tube here is concentrated, right? So you find that C4 in this case, okay? And then you work backwards, right? So using a C1V1 equals C2V2, right? You're going to go and find how much the concentration was when you had it taken up from this pipette, right? So the concentration when you have it in the pipette is unknown, right? That's C3. V3, well, you either took 0.25 or 0.5 mils, right? So C3V3, right, where C3 is your unknown, is equal to C4V4, right? Remember, our concentration for we're going to find from our standard curve, and V4, right, is 6 milliliters. That was our volume. So you can find, when you aspirate this, how much is going to be the concentration in this little amount that you aspirated. Now, remember, you aspirated up this serum albumin from this test tube here, right? This test tube here, it's going to have the same concentration as what you aspirate over here, right? So C2 and C3 are going to be exactly the same. Why is that? If I take a very dark coffee, right, very concentrated coffee, and I put it in a smaller glass, is the concentration going to change? No, right? The concentration is going to stay exactly the same, all right? So the concentration between this is like, you're not adding anything, you're just taking a smaller volume but also a smaller mass, right? So C equals M over V, you're still taking the same amount of this whatever solute you have, right? So basically you're going to be having the same concentration between these two. So C2 is equal to C3. And now you just need to do one more C1V1 equals C2V2, right? Here we have a concentration that you now found. You have a volume, which is 12 mils, is equal to, right? Here you have the unknown concentration 1 that you want to find, and the volume of this that you didn't see was 2 milliliters, okay? So from this, you should be able to work backwards and calculate what that initial concentration was in this tube of 2 milliliters.